So for this problem, so we'll just do this. So let's say suppose, okay, because we're trying to find the volume, largest volume of the right circular cone that is inscribed here, right? Okay. So we know that this is, so this is the radius of it R. This is also the radius R. So I'm just going to call this X, this right here. I'm going to call it X. And this is also the radius, right? So that's R. Okay. And then what I will do is, okay, so I will do this now. So maybe we should, okay, so the radius of the, yeah, so the radius of the, yeah, the radius of the sphere is going to be, okay, so the radius of the cone is R, like this is R, and maybe I should call this one differently. I should call this the big R. This is the big R. Yeah, because they're not the same, so let's call that big R. So therefore, the radius, I mean this distance here, which is the height of the cone, so that will be h r plus x. So then I will write it like this: r h. You know, the cone is like this. The cone is like this, and this is the height of the cone, which was this distance here. So part of it is x and part of it is r. So this is r plus x. So h equals r plus x, and then I can find the, using this right triangle here. Then we also have x squared plus r squared equals the capital R squared. Then r squared equals capital R squared minus x squared. So now I can just write the volume of a cone, which is 1 over 3 pi r squared times h, and r squared is this times h, which is r plus x. And then compute the derivative of this. So derivative of that with respect to x, that's going to be 1 over, this is constant, so we keep this, and this will be, so the product rule, I guess we have to use product rule here, that's negative 2x times r plus x, or you can multiply and then take the derivative. That might be easier actually. So if you just compute the derivative of this, after you distribute it, so let me just distribute it first, and then we'll do the derivative. So that's r cubed plus r squared x minus r squared, rx squared, r times x squared minus x cubed. Now do the derivative. When you do the derivative of this, this is going to be 1/3 pi, and then this is 3r squared, 3r squared. I mean, this is 0 because this is constant. R cubed is constant, so that's 0. So then this is r squared. Okay, r squared minus 2rx, and then minus 3x squared. and then you set this to 0. So you set this to 0, and R will equal to, when you set this to 0, R will equal, X will equal 2, because you're solving it for X. So X will equal to, if you solve this for R, X will equal to R over 3. So X is R over 3. Now you can plug it back into the volume equation. Okay, so if you plug it back into the volume equation, then we should get, so take this guy and then plug it back into this for X. And then it's asking for the volume of a cone. So when you plug this back in here, and then you will see that the largest volume is 32 pi R cubed over 81. So just take this value and plug it in there to do it.